Welcome back. We're going to be talking about transformations of functions. Now there's a few key transformations, and actually if you learn all these, they are super good for trigonometry, trig functions, especially talking about sine, cosine, tangent, and the likes. Okay, so there's a few. There's shifting the graph, right? So vertical shift, we are adding to a function. So if you notice, with vertical shift, we are going to have a function, f of x, and we're either going to add or subtract c. Okay, if you plus c, it is a upwards. Okay, if you subtract c, it's downwards. Okay, horizontal shift is going to be inside our function, where we add or subtract c. Okay, so plus c is actually going to be to the left, and subtract c is going to be to the right. And that is actually all you need to know, okay, for vertical and horizontal shifts. So vertical is just going to move it up, the arrow up, downward is going to be down arrow, left is going to be here, right is going to be this way, okay? So if you understand that, that's a pretty useful concept for quite a few problems. But let's keep moving. So graph the function f of x equals x cubed. And actually, I want to show you some stuff with this. So at the end of this, I'll open up Desmos and we'll go through some shapes, okay? So we actually get to see the comparison, okay? So I'm going to skip over the examples and then come back, okay? Reflecting. Reflecting is actually a pretty straightforward concept. So reflecting. If you have h of x equals negative f of x, that's going to be a reflection over the x-axis, okay? So think the x-axis, it's a reflection this way, okay? And then h of x equals f of negative x is going to be over the y-axis, okay? So that's going to be the y-axis up and down. It's going to be over the y-axis, okay? Now, can it flip over and back? Yeah, you could actually do some of that stuff. Finding equations for graphs, we'll again look at some stuff, so we'll skip over this, come back. And then they combine stuff, reflections plus shifts, what would that look like? What does that do? How do they combine? Non-rigid transformations. Okay, this is actually some key stuff. So rigid transformation, it doesn't change the shape. Okay, so that's a shift. So rigid, our list is shifts and reflection. Okay? So non-rigid does change this shape. So that would be stretch or shrink. Okay? So thinking about that, what we would have is stretches. So if we have h of x equals c of f of x, okay? If c is between 0 and 1, so it's a fraction, people, it's a fraction, this would be a vertical shrink. Now, the way I think of a vertical shrink, I think of if you had a bowl and someone started smashing it down so that it becomes wider, okay? That's a vertical shrink. Now, if c is greater than 1, you have a vertical stretch. And if you think of that, that's like taking a bowl and someone pulls up these ends, pulls them up, so that they go, they're very thin, okay? So that's vertical stretch, and this is vertical shrink. Now, I know these drawings look weird, but hopefully it communicates the same meaning. So actually, I'm gonna erase this and then write horizontal stretch and shrink. So horizontal and vertical actually kind of have a relationship. What I mean by that? I mean that horizontal actually can affect vertical, and likewise, vertical can affect horizontal. So if you have some h of x, and you have f of c of x, okay, so if c is between 0 and 1, you're going to have a horizontal, and I'm just going to, you're going to have a horizontal stretch. This would be like someone pulling it out this direction so that it would get wider, okay? So if you notice, it looks kind of similar. Stretching it. If c is greater than 1, you have a horizontal shrink. Okay? Horizontal shrink. So you have this, and someone presses in on it, okay? Which then it gets thinner. Notice that these two drawings are very similar at the end result to what we did with vertical, okay? It has the same kind of look with the end result, okay? Now let's look at Desmos. So I'm going to open up Desmos, and it's a beautiful thing. Okay, it doesn't matter, we don't need to log in. Let's just go to graphic calculator. Okay, so if you're in with us, I'm going to open up Desmos. I'm actually going to blow it up so that this is the full screen. Okay, so let's take a beautiful function. Let's take y squared. Okay, so what happens when we shift it? So y equals x squared, that's plus 1. Notice we went up. What about minus 1? We went down. Okay, if you need more help with that, let's minus 3. Okay, do you see how we went down? And plus 4 went up. Okay, now how do we do a horizontal? So we actually have to get inside this x squared, put parentheses around our bad boy. Actually, no, we'll do that. Okay, minus, let's say plus c, and then we'll square it. Okay, add a slider for c. Okay, so notice c is positive. We're going to right. We're going to left. So c is plus c. We keep going to left. Okay. Okay. Now what if we added a negative here? Okay. So we're minusing c. Okay. So we minus c. What happens? If we minus c, we go to the right. Okay. So plus c to the left, minus c to the right. Okay. What about negative in front? Flips it. What about negative on the inside? It flips it over the y-axis. Why didn't this change? Good question. Why didn't it change when we did that? What happened? Well, what's this? This is an even function. The rule with even functions is that if you plug in a negative, it will still stay positive. Okay? What if this was cubed and this was cubed? Sorry, that's not cubed. It's cubed. It's not just randomly 3. What happened? So we have our original subtractor. Notice it flipped. Now we've got our DNA going on. Okay? Now let's look at non-rigid transformations. Okay? Let's start with this one. So non-rigid, the outside is vertical shrink. Oh, sorry. We gotta start with our normal. And let's start with 1/4 x cubed. Look what happened. Actually, let's put a c right here. Let's add a slider for c. Okay? At 1, there's the same. What if we start getting bigger? Notice what's happening. We're getting closer to the y-axis. And as we keep getting bigger, it keeps stretching out, keeps stretching out, keeps stretching out, keeps stretching out. What about when we get closer to 0? What's happening this way? We keep getting wider. Okay? Notice how wide we get. Okay? And then negative flips it, and it's same stuff happens. Let's do y squared instead of cubed, so we get a better picture. So notice how stretched that is, okay? And then as we get closer to 1, you know what happens when we get wider? It gets wider. See kind of what I meant by the bowl? It kind of gets smushed in it. Okay? It's like someone's pressing down. What if this guy? Okay. So I put the C inside. So now we're talking about horizontal. Now, that's pretty wide. Horizontal is pretty wide. And then notice, horizontal looks the same. We kind of smushed it. Okay? Same thing happens. Okay? So it has more of a stretch, actually, kind of, right? That's because it's affected also by that square. Okay? So that's the basics of graphing right here. Okay? So how I'm going to do this. Okay? So that's a simple way of looking at graphing, and I hope you understand and know how to apply it. Thank you guys so much for joining. I do have the notes up if you want to look at them. You can just fill them in as you need and practice the sketching. I would say practice the sketching on Desmos to just get the concepts. Okay? Okay, thank you guys so much. I'll talk to you guys later. Bye.